All right, for number 3, we want to find the complex conjugate. So we need to recall if we have any term, a plus bi, mainly we've been seeing binomials, a plus bi. The conjugate, and they just call it complex conjugate because it's imaginary, but that could be the case for any term. Remember, anything could be complex. The complex conjugate would just be the same terms, a, bi, but we just change the sign here in the middle. So if we have a plus bi, the conjugate is a minus bi. If you have a minus bi, the conjugate is a plus bi. So in this example, we have a negative 9 plus 5i. Okay, so the conjugate, we're going to do the same terms, negative 9 and 5i, and we're just going to change the sign in the middle. So this is the complex conjugate. Negative 9 minus 5i. Okay, number 4 says the information about the given polynomial whose coefficients are real numbers. We're going to find the missing zeros of f. So they tell us degree 3, which means we have 3 zeros. Okay, so degree 3, we have 3 zeros. And they give us 9 is a 0, and then they give us 8 minus I is a 0. Now recall from problem 2, I was mentioning that if you have an imaginary, you're going to have 2 terms. You're going to have the positive and the negative. Right here we see 8 minus I. And kind of like the complex conjugate, that's the idea we get. It kind of comes from that as well. We should have another one, 8 plus I, because that comes from square root. Anytime you have square root, you have plus or minus. So if I have an imaginary term that is negative, I have to have the positive and vice versa. So these two are pairs. This one is the missing term. And you just kind of get that from knowing the fact about complex numbers. So the remaining zeros are 8 plus I. Well, that's the only one that's left.